We're going to go ahead and go over this worksheet that most classes started with. I have it labeled topic number 6C worksheet. Yes. And this is given. The first statements I've went through and just copied them all as given because that's where we always start. We start with the given information. Based on the fact that they gave us this information, this is a midpoint. So since this is a midpoint, we know that AC equals CD. Well, AC equals CD. Why? Like I said, because it's definition of midpoint. And then from there, we can substitute what we know AC to be is 4x and CD to be 2x plus 12. So we're using substitution. Property of equality. So I put POE as property of equality. Then from there, I look at the difference between this step and the next one. Well, I subtracted 2x from that side to get there. Did the same thing to the other side. If I'm doing the same thing to both sides, and I'm subtracting, that's going to be subtraction property of equality. And again, I compare my step 4 to go to 5. The 2 disappeared on this side, and that was being multiplied. So I divided by 2. I divide this by 2. That's the division property of equality. Now I have listed all my reasons or justifications to what was happening under statements. So division property of equality. And that's that first proof in completed form. Then number 2. Again, I start with the given information. I look at 4 and 2. I have this is given, and I have this picture to be given. Well, 4 and 2, if they're comparing these two, those are vertical angles. So vertical angle theorem tells us that they're congruent to one another. That's vertical angle theorem. Then 1 and 2 being congruent. Well, there's nothing in the picture that tells me that they're congruent. But if I look at both steps above, 1 is congruent to 4 and 2 is congruent to 4, so then 1 would be congruent to 2 is the transitive property. Of congruency, since we're dealing with congruence, not equality, as we did with number 1. Then from there, we have 1 is congruent to 1 and 3. That's these two angles. Again, I don't have anything above that's going to give it to me, but the picture gives it to me in vertical angle theorem. So that's vertical angle theorem, is because 1 is congruent to 3. And then from there, if 1's congruent to 2 and 1's congruent to 3, then 2's congruent to 3 is, again, transitive property of congruency. So that gets us through number 2. The last problem on this side of the worksheet, we were given 1 to be congruent to 3. 3 is congruent to 6. If I look at 3 and 6, those are vertical angles. So vertical angle theorem tells me 3 is congruent to 6. They want me to use the transitive property of congruency. Well, that means I need to use a couple steps above. Well, I only have 2 steps. 1 congruent to 3, 3 congruent to 6. Then angle 1 would be congruent to angle 6 by the transitive property of congruency. 1 and 4, we have another pair of vertical angles. So vertical angle theorem tells us that those two are congruent. And now these last two steps give me 6 congruent to 4. A lot like this picture looks a lot different than this number 2. But actually the last steps here, in fact all the steps are very much the exact same. This is a transitive property. Of congruency. So that was 1, 2, and 3 on that side. We have 2 problems on the other side. Go on to number 1. Number 4, the first statement, obviously, I've rarely seen any situation where you don't start with the given information. You want to get that into your proof. Once you have 1 congruent to 3, I don't see anything in the picture that's going to give me something like this, but I can tell you that I'm adding measure of angle 2 to both sides, so the angle addition, the addition property of equality would give that to me. Then, what makes 1 plus 2 equal to AEC? Well, that's the 2 parts equal the bigger one. That's angle addition postulate. It's just an understanding we have. If we can add the 2 smaller ones that make up the bigger one. Same thing for DEB being 2 and 3, angle addition postulate. And then from there, we have AEC is equal to DEB. What's happening there? Well, if you look at it, this related to this, and this is related to that. That allows us through substitution. If we substitute AEC in for that and DEB into that, we get exactly what we're trying to prove. So by substitution, property of equality, we can state what we were trying to prove. I have one more proof at the bottom of this page.